Hello and welcome everyone to the quick solution of All India AIATS Test Series Medical 2020, Test number 7, Code CND, dated 3 March 2019. I am here to discuss the physics portion, so let us get started. Here is question number 1. If two objects A and B of same volume and same density are dropped from a height of 200 meter, then if we are neglecting the air resistance, which one of the following will be correct? We have to pick the correct option. We know very well the time taken for any object to reach the ground if released from some height is given by under root 2h by g, where h is the height from which it is dropped and g is acceleration due to gravity. The speed of object while hitting the ground is given by under root 2gh. If we see both expression, we can say that the time taken as well as the speed is independent of volume as well as density of objects. So that is why we can say that they will reach the ground at the same time and they will hit the ground with the same speed. So after looking at the answer, we can say that option number 1 will be absolutely correct. So this was question number 1. Now let us proceed to the next question, that is question number 2. Here is question number 2. The dimension of Planck's constant is identical to. So first of all, let us see what is the dimensional formula of Planck's constant. We know that the energy of any incident photon is given by E equals h into nu, where nu is the frequency. So we can say that the dimensional formula of h will be the dimensional formula of energy E divided by the dimensional formula of frequency nu, where h is the Planck's constant. Energy dimension formula we can write ml square t minus 2, and the dimensional formula of frequency we can write t to the power minus 1. After solving, we can say that the dimensional formula for Planck's constant will be ml square t to the power minus 1, and ml square t to the power minus 1 is also the dimensional formula for angular momentum. So we can say that the dimensional formula for Planck constant will be same as the dimensional formula for angular momentum L, where L is angular momentum. So if we find the option, we can say that option number 2 will be absolutely correct. The dimensional formula for Planck's constant will be identical with the angular momentum dimensional formula. Now let us proceed to the next question, that is question number 3. Here is question number 3. A fixed mass of an ideal gas is compressed in such a manner that its pressure and volume can be related as P cube V to the power 5 equals constant. During this process, what will happen with the temperature of the gas? Here, gas is compressing. So we can say that volume is decreasing. And we have to find out what is happening with the temperature. An expression is given between volume and pressure. P cube V to the power 5 equals constant. We have to relate volume with temperature. It means we require the relation between volume and temperature. So let us start. From the ideal gas equation, we know that PV equals nRT. Therefore, we can write P equals nRT divided by V. Let's plug the value of P in equation number 1. We will get N cube, R cube, T cube whole divided by volume cube multiplied by volume to the power 5 as constant. Rearranging the values, we can say that T cube V to the power 2 is constant. Finally, we got the relation between volume and temperature, that is T cube is proportional to 1 by volume square. So from the expression final we can say that if we decrease the volume, temperature will be increased. So here V is decreasing. So that's why we can say that the temperature will increase. After looking the options, we can say that option number 1 is absolutely correct. So that's why we will go with option number 1. Now let us proceed to the next question, that is question number 4. So here is question number 4. A rain is falling vertically downward with respect to ground. A girl running on the ground with speed 3 km per hour observes the rain falling with speed 5 km per hour. The actual speed of rain is what? Suppose the actual speed of rain is VR, which is we have to find out. The actual speed of girl VG is given in the question, that is 3 km per hour, and the relative speed of rain observed by the girl, that is VRG, is also given, that is 5 km per hour. The question belongs to relative velocity in 2 dimensions. So let's try to analyze the situation. Suppose the girl is running this way horizontally VG. According to question, the rain is falling vertically. So the speed of rain VR in vector form here. Now according to the concept of relative speed, we can say that vectorially VRG is what? VR minus of VG in vector form. Otherwise we can write VR plus of minus VG, where VR and VG, two vectors perpendicular to each other according to the question. So this is the expression for VRG, and after looking at this expression we can draw our diagram something like we require minus VG vector, which is opposite to plus of VG. So this is minus VG vector, and the resultant we will obtain from the parallelogram law of vector will be VRG. The rain will appear to the girl something like this. Now from the above equation VRG equals VR plus of minus VG, we can write the magnitude of VRG as VRG square equals VR square plus VG square. Now putting the values, VRG is 5, so that's why 5 square equals VR we have to obtain plus VG square, that is 3 square. After solving we get VR, magnitude of velocity of the rain, that is VR, we will get 4 km per hour. So this is our answer, and after looking at the options we can say that option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question, that is question number 5. Here is question number 5. The variation of force acting on a particle of mass 800 gram with position x is as shown in figure. The time period of oscillation of the particle will be what? Now from the graph we can say that this is a straight line, and we know very well the equation of straight line will be given by y equals minus mx. Now the axes are here, force and displacement or position x. So at the place of y we have to use f equals, what will be the slope? Perpendicular upon base, that is 8 divided by, this is in centimeter. We are supposed to write in SI system because answers are in second. So that's why minus of 8 upon 0.1 x. Now mass is given, we can write the acceleration A equals minus of 8 divided by 0.1 multiplied by 0.8 kilogram is mass. So 0.8 x. Now comparing the equation we have got with the equation of SHM, that is A equals minus of omega square x. What we will get? We can get omega equals 8 divided by 0.08 under root. After solving we will get 10 radian per second as our omega. Now about time period we are very much clear that t equals 2 pi by omega. Putting the value of omega we can get 2 pi divided by 10 radian per second, that is time period is pi by 5 second. So we have got the time period of oscillation, that is pi by 5 second, and after looking at the options we can say that option number 2 is absolutely correct. So that's why we will go with option number 2. Now let us proceed to the next question, that is question number 6.